This is Srikanth, working as assistant professor in electrical department. So in this video, I want to discuss about AC as well as DC theorems, procedure and problems. We'll discuss in this video. We have like different theorems: superposition theorem, intelligence theorem, maximum power transfer theorem, Thevenin's as well as Norton's theorem, Millimeans theorem, compensation theorem. So we have different theorems. So we'll check it one by one now. So coming to intelligence theorem, AC or DC. So don't bother about like excitation, AC excitation or DC excitation, no problem. But we require the procedure. So and what is the statement? So coming to intelligence theorem, we have like one circuit at the AC circuit or DC circuit. So any one circuit. So that circuit, the power, so total power is 0. AC or DC no problem. But we need to know how to do the procedure. Suppose I have one circuit. For circuit, I have a number of resistors, a number of inductors, a number of capacitors, and we have like different sources. So for that particular circuit, so for each element, what is the power? So what is the voltage? What is the current? So first we need to find out the current, and then we need to find out the voltage. Then V into I, that is your power. So for each particular places, the sum of power in total whole circuit. Otherwise, you can say like which supply we have, which supply wattage we have. The total watts is equal to delivered in the circuit. A total sum of power equal to 0. And just remember, there we have the positive and negative. Okay. Suppose here I have a circuit. For this circuit, I have the negative as well as positive. So negative we have, positive we have. And same thing here I have one circuit. In suppose here I have one source. Direction is downwards, current direction. So we have negative and positive. Otherwise, here I have one circuit. Here direction is upwards. Then we have the negative and positive. Just don't forget the negative positive. Here we have the positive negative, and here we have the negative positive. And just observe. So which we have the negative and positive, negative, and here also like a positive, then negative. So which value we have? Just substitute that power. Okay, and I have a problem here. Suppose AC or DC, no problem. Suppose here I have like voltage source for DC and some resistors. Simple circuit. So 2 resistors I have, 1 voltage source. Then I will find out I need to prove the theorem. So theorem means no need to find out some different values. We need to prove that particular theorem. So here I have voltage like 10 volts and 2 ohms, 3 ohms, suppose. So I want to prove the intelligence theorem for this circuit. So for this circuit, I want to prove the intelligence theorem. Then we need to find out the current as well as voltage. We need to find out the current as well as voltage at each places. Okay. So here I have the negative, positive, then positive, negative, and positive, negative. So this is my circuit. Now I need to find out the current and voltage. So it's like closed path, single loop I have. So I can find out the current easy. So you can use any method. So there is no condition. You need to use like a source transformation. You need to use like current division rule. You need to use like voltage division rule. You need to use like mesh analysis, nodal analysis, or any other method. So you can use any method and find out the current voltage values. Okay. So for single loop means I have like current value I equal to V by R. So I know the V value 10 and R equal both resistor in series. So 2 plus 3, I have the answer like 2 amps. So I have a closed path. So 10 by 5, we have the 2 amps. So I have a current value. Closed path, which current we have here? That is 2 amps. Which current we have here? 2 amps. Here also. So single loop, I have single current. If you have the 2 loops, we have 2 different currents at 2 different places. I need to find out the current values. Okay, and then here I need to find out the voltage. So I have the current values. Here I have the voltage, but I don't have any voltage here. So just find out V into I. So V equal to I into R. So I know the I value 2 amps. R equal to 2. We have the 4 volts. And here I have current value and resistor value. Then same 2 into 3, 6. So I have the voltage as well as current values. I have a voltage as well as current values. Each place. Then find out the power. So here how much power we have? So V into I. So V into I, that is 20 watts. Here how much power we have? 2 into 4, 8 watts. Here 6 into 2, 12 watts. Then summation of power equal to. So 20, that is minus 20, then plus 8 plus 12. So how much we will get? 0. So not only this circuit, any type of circuit. So suppose I have like a voltage, resistor. So I have like n number of resistors. So this type of circuit. Then also we need to find out the voltages and current particular each places. So V and I using any method. So there is no condition. You can use any method and find out the values. Coming to AC, we have like a voltage source and current sources. We have different sources we have. So not only resistor, we have the inductor as well as capacitor. Okay. So we have different elements. So we have 3 passive elements. So for that, and find out the again. So what is the voltage drop here and what is the current? What is the voltage drop and what is the current? What is the voltage drop and what is the current? What is the voltage drop and what is the? So we need to find out the each place's power. Then summation of total power. But coming to AC, we have some you need to use some techniques to find out the current and power values. Otherwise, calculation is more difficult to find out from AC circuits. Okay, so for AC circuit, we have like a V equal to I into impedance. So here we have the impedance values. Clear? For capacitor, we have XC and inductor, we have XL. XC means again that is minus J, will get minus J and something value 4. And coming to XL, we have like J4. Here we have the plus values for inductor. For capacitor, we have the minus values. And for if you want to convert into polar form, we get like for capacitor. For capacitor, 4 same minus J we have, but we will get like 4 angle with 90. Okay, and here we have like 4 angle with 90, but we have plus. Here we will get like minus. Okay, otherwise in real values, if suppose as a resistor, for resistor we have like same 4 ohms we have, then the angle for resistor we have 4 angle with 0. So we have the J. So for AC circuit we require the J notations. So here we have like a 1 J square, and here we have like a minus J. So we require the J notations. For J notations, so we have like a at 0 degrees, 90 degrees. This is like 270. So different places have different values. We can write directly also, no problem for that. Okay, and coming to one more theorem, that is superposition theorem. And superposition theorem means we require more than one sources, not one sources. So superposition theorem applicable for more than one source. When we have like 2 sources, 2 or 3 or any source, so like more than one sources I have, then the response per particular branch. So if you observe the circuit here, so I have a voltage source and current source. So at particular branch, I have some response, that is I. That response is equal to the individual response occurs. So from this source, for individual source, my response is I1. For this individual source, my response is I2. Summation of the response for each sources. Then what about remaining sources? So I have 3 sources. So I have a voltage source and current source. For this particular circuit, I have one voltage source and one current source. So one voltage source is acting. Then what about the current source? Current source replaced with their internal resistance. Nothing but it's open circuit. Coming to voltage source replaced with their internal resistance. Nothing but your short circuit. It's short circuit. Here current source is open circuit. Here voltage source is short circuit. Then find out the response. And here also. So there is no condition. You can use any conditions, any method and find out the values. Okay, suppose I have like a voltage source and resistors and here I have like one current source and one resistor and one more source you can take consider, no problem. So this is my circuit. Okay, this is my circuit. So I find out the, so I need to prove the superposition theorem. And prove the superposition theorem means I require more than one source. So I have here three sources. So for three sources I need to find out the response. So prove means so in exam or any particular like a problem. So I have to find out the current using superposition theorem means just find out the current using three responses. Otherwise, I want to prove the superposition theorem means we need to prove when three sources is acting, then we need to get the current value and the three individual currents. Then we need to prove the values. So suppose I want to find out the current using superposition theorem. So that is your I value using superposition theorem. So no need to find out the current when 3 is acting. So when 3 is acting, no need to find out. When I need to prove the theorem, then I need to find out the I value as well as I1 value, I2 value and I3 value. So I1 means V1 is acting and I2 is current is acting and I3 means V2 is acting. So when individual source is acting, then we need to find out the I1, I2, I3 at same branch. I1, I2 and I3 at same branch. Then prove means I equal to I1 plus I2 plus I3. Prove means we need to find out the 1, 2, 3, 4 circuits. 4 circuits current. Okay. So I need to find out the 4 circuits current. So this particular circuit, find out the I value. I value means when 1, 2, 3 sources is acting, then find out the current value. So you use any method. Source division rule, current division rule, or source transformation, or voltage division rule, or Kirchhoff's laws, mesh analysis, node, or any method you can use and find out the I value. And then I1 means V1 is acting. So only V1 is acting. Then remaining sources is replaced with their internal. So current source is open. Then this voltage source is short circuit. Not like we don't have any voltage source here. It's short circuit. Now find out the response here. That is I1 response. So V1 is acting. Then find out the response here. Same thing. Now current source is acting. So then I need to find the I2 value. So 2 voltage sources is short circuit. And here I have a current source. So when the source is acting, then also there is no condition. You can use any method and find out the I2 value. Same thing, V2 is acting, remaining is replace their internal resistance. So this is about like a superposition theorem. Coming to AC circuit for superposition theorem, same, but there we have like AC. AC means we have voltage. So voltage source, resistor, inductor as well as capacitor. So we have like a passive elements. 3 passive elements we have. And we require one more source also. So here I have like a one current source otherwise. Current source 2 amps and 2 angle 0 amps and here 50 volts angle 0 and R 2 ohms J 3 and minus J4 and here we have like a 2 3 different values. So for this particular circuit we will find out the superposition theorem at particular response. So any place I want to find out the response here or here or here. Okay, then we need to use like any method, but here just remember we have the impedance values. And check it which method we have like a easy to use. So for me, for these circuits I can go for like a current division rule, voltage division rule. Otherwise series parallel also. So for when the current is open circuit here, so only voltage is acting and find out the response at particular 3 ohms branch, then it's open. So we can use mesh analysis. I1 and I2. Which I2 current is nothing but your 3 ohms current. So when current source is acting, voltage source is short circuit, then go for the series parallel. Then we have the current source. So when voltage source is short circuit, I have the resistor and inductor and capacitor. Okay, and here I have like resistor at 3 ohms branch and it find out the current. So for this type of problem, so these two are parallel. So this is Z1 and this is Z2. So Z1 parallel Z2. So we have a Z1 into Z2 by Z1 plus Z2. Then we'll get like suppose Z3. So Z3 series with this 2 ohm resistor. So Z3 plus 2. Then we have one impedance here, that is Z3 plus 2, and here I have 3 ohms resistor. And here I have a current source. Now use current division rule. So I require this current, so opposite resistor by this resistor. So IS into opposite resistor, that is Z3 plus 2 by your total resistor, Z3 plus 2 into, so plus your 3 ohms. Just use the logic, that's it. You can use any method, no problem for that. Coming to one more, we have reciprocity theorem. So reciprocity means, just remember, replace. Just replace. So I have one circuit. So I want to find the particular branch. So individual resistor current. When the voltage source is replaced the branch and find out the voltage branch current. The both are same. So if you observe the circuit here, voltage source, and I want to find the response here. I want to find out the response here, and here that response is equal to the voltage source is replaced here, and response I want to find out the voltage branch. So remaining circuit is as is. So don't disturb the remaining circuit. Remaining circuit is as is. So don't disturb. But the voltage source is replaced. Then the response is equal at two particular positions. Okay. And coming to one circuit here. So voltage source and resistor. So any type of circuit. There is no. So capacitor. For AC we have a capacitor and inductor and resistor. So consider any one type of circuit. There is no conditions. Okay. So here I have one circuit. So a particular response. So I want get the like and prove the theorem means at particular place. So coming to particular place. So here I want to find out the response. So suppose I value, then that I is equal to same circuit, but here the voltage is replaced at this branch. So remaining circuit is as it is. Now I will find the response at this voltage branch. That response is equal to this response. Okay, that AC or DC. So again, there is no condition. You need to use this rule. You need to use this rule. You can use any method, but we need to know the which place I need to replace, which place I need to find the response. So I need to prove the reciprocity theorem means where I need to find the current and where I need to prove that current is equal. Okay. Now coming to, we have more Thevenins and Nortons. So Thevenins and Nortons both are same. Both are same, and statement also similar. When we have like a n number of voltage sources, when we have the n number of voltage sources, n number of sources, not only voltage sources, n number of sources and n number of elements, passive elements is equal to, easy. For DC means n number of resistors, for AC means n number of passive elements. Is can convert, so that circuit, whole circuit can convert into single circuit, that equivalent circuit having only one voltage source, series with one impedance or one resistor. Coming to Norton's theorem, here voltage source, but Norton's theorem we have like current source, and here impedance is series, but here parallel impedance. So voltage source series with one resistor. Here current source series with So parallel with that resistor. Okay. So here I have circuit. So total voltage sources, resistors. So resistors I have like an inductor, capacitor. So different type of circuit. So for this total circuit convert into one voltage source series with one resistor. Resistor means in DC, impedance means in AC. Okay. And load resistance. Suppose my capacitor is low now. So this is our capacitor. This as it is. So your whole circuit is converted into voltage source and one impedance. For DC we have like voltage source with resistor. And coming to Norton's theorem, so whole circuit convert into current source parallel with one impedance. Capacitor is as it is. And here we have, for DC we have like current source parallel with resistor. Capacitor is as it is. Okay, and we have any conditions. So total circuit converted to voltage. What is the voltage value? How will we find out the voltage value? How will we find out the impedance value? For Norton's and Theorems, the impedance and resistance value is same. Suppose here my load resistance. Okay, just remove the load resistance, and find out the equivalent value between A and B. So remove the load resistance. So remaining circuit. So which we have like voltage or current DC or AC. So no need to worry about the AC and DC. So procedure is same. So the circuit, which circuit has every element is same. Okay, every element is same. But at last between A and B, I want to find out the equivalent value. But finding the equivalent value, here are the source. So here source we have. Here I'll suppose a current source. Okay. Here I have the voltage source. Here I have the current source. Then what about two sources? When we have the two sources, I can't find out the equivalent value. So what about these two sources? The two sources is replaced with their internal resistance. Same. So voltage source is short circuit and current source is open circuit. It's very simple. Okay. Just find out the logic. So I need to find out the equivalent value, that is a Z impedance here for AC Z. For DC you have the resistor. So ZTH, here this is ZTH and this is your Zn. And this is RTH and this is your Rn. So ZTH is equal to Zn. RTH is equal to Rn. Common. Actually both procedure and both like values is common. There is no change. So the current source is open circuit, voltage source is short circuit, then find out the equivalent value. Coming to DC, coming to like a voltage source and current sources. Coming to voltage source and current sources. For voltage source, we need to find out so circuit is as is. So there is no open circuit, there is no short circuit. For the voltage source and for the current. So current source, voltage source we have. So whole circuit is as is. Remove the low resistance. So the capacitor is removed here and find out the open circuit voltage between same point. At AB point and find out the open circuit voltage. At AB point and find the open circuit voltage. And coming to that voltage is your VTH. And current is find out the short circuit. It's same place and find the short circuit. And which current we have this short circuit. That current is your IN current or ISC current. Here VTH or VOC voltage. Same place. There is no like a different place. Where you have the load, that place and it go for the short circuit and open circuit. Open circuit voltage is nothing but your VTH. Short circuit current is nothing but your IN current. Norton's current. Thevenin's voltage, Norton's current. The procedure is as it is. For Zn and ZTH, both are same. RTH, Rn, both are same. So voltage is open circuit voltage, current is short circuit current. Here you can use any method. Same, any method you can use. Source transformation or mesh analysis, any method you can use and find out the particular branch response. So particular place, voltage value and current values. Okay, and coming to maximum power transfer theorem. So maximum power transfer. So and transfer the maximum power at particular place. So which place that is? That is load place. So and find out the maximum power to some place. That place is your load. So where from? So from is your source to your load. So when I can transfer the maximum power to the load means the source resistance is equal to the load resistance. So when source resistance is equal to the load resistance, then I can transfer the maximum power to the load. Okay, and the formulas, current formula. So only one loop means where the current, and power is V square by 4R. You can substitute those values, you get the answer. Okay, and remember guys, so here one logic is any circuit. So we have different circuit, AC or DC. No need to worry about AC and DC. Okay, so for particular circuit, this is my, suppose here I have one load resistance RL. So I don't know RL value in exam for maximum power transfer theorem. So I don't know RL value. He will like every values. So each value he'll put. He like a 5 volts, 10 volts, something. We have the each value, but I don't know RL value. Just find out the RL value when the maximum power transfer to the RL place. Then you need to go for the maximum power. So maximum power means you need to convert this whole circuit like Thevenin's or Norton's. Thevenin's or Norton circuit. Thevenin circuit means one voltage source series with one resistor, like one impedance, and here current source series parallel with one impedance. Here we have the RL. Then what is the RL value here? In this condition or in this condition, the RL value is nothing but your Rn value. So Rn value, guys. So for this circuit, you want to find out the equivalent value, R equivalent. When load resistor is open in between this point, AB point, so we need to remove the load resistance, and at this AB point, and find out the equivalent value. So voltage source is short circuit and current source is open circuit. Then find out the equivalent value. That equivalent value is nothing but your Rn value. That is nothing but your RTH value is equal to RL value. So RL is equal to RL. So Rs is equal to RL. Then the maximum power transfer to the load. So in this condition, we have the Rn is nothing but RTH is nothing but your RL value. For this condition, nothing but Rn is nothing but your RL value. That's it. So in maximum, in any kind of exams or any gate exams or any competitive exams, we have this type of problems. Okay, and coming to, we have one more Milliman's theorem. We can say like parallel generation theorem. So parallelly we have practical voltage sources or practical current sources. We can convert to again Norton's and Thevenin circuits. So we have n number of voltage sources series with resistors. You can convert that to single voltage source, single resistors. That is nothing but your Milliman's theorem. So here we have one current source, resistor, current source and resistor, current source and resistor. So we have the n number of, there is no condition. So we have the n number of, suppose here 3 we have, and here suppose RL we have. Then these 3 connected to one place. So between two nodes I have the current sources. So each current direction is same. So here suppose I1 value, I2 value, I3 value. So same, each current direction is same direction to a particular node. So your equivalent current is I1 plus I2 plus I3. If suppose the current direction reverse, so minus I3. And resistors. So 3 resistors connected in parallel. Parallel means we have the formula, parallel formula, that is 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. It's very simple, guys, if you know the formulas and if you know the logic. AC or DC? For AC, we have like a impedance. For DC, we have the resistor. That's it. So procedure and your statement is same. Okay. So which procedure we have, which method you can use? You can use any method. So there is no condition. For AC, we can use like which method? Simple. Use that simple method only. Okay. Don't go for like a large equations, all those things. Okay. And coming to, we have one more theorem, compensation theorem. So I need to compensate some voltage to particular branch. So I need to compensate some voltage to particular branch. So how much voltage I need to why I need to compensate? So any circuit, suppose I have like a voltage resistor, and here I have like one small circuit. For that, here in this resistor, some disturbances occur. Some voltage is some temperature, otherwise some temperature increase, automatically the resistor value will change. So the resistor value change means we have added one more resistor here. Actually here we have 10 ohms, but 10 ohms and 2 ohms is increased for this total resistor. For this particular branch, I have only 10 ohms, but it's increased to 12 ohms. Then the actually here source I have suppose I current, but here I can't get the I current. Automatically the resistor will change means the current value will also change. Then how much voltage I need to compensate this particular branch? That is nothing but your compensate theorem. So like this theorem, we have one small condition. So I have the I value. So at this particular branch, that is your I value. So this circuit and find the I value, and which voltage we need to compensate means here circuit is as it is. Here my voltage is how much voltage means I into R delta value. So here V we know, and here R I know some R1, R2, R3, RL, and this is a R delta. So increased value 2 ohms. So your I, which I we have when the circuit is, we have general circuit, from that general circuit which current, actual current into your R delta is the compensate voltage. So coming to circuit here, so I have voltage source and here I have the response. Now here some delta value is increased. Now I will compensate some voltage at a particular pace. So that is VC into your value. Okay. So I want to prove this theorem means, I need to prove this theorem means, and find out the, from this circuit and find out the I value, from this circuit and find out the I dash value, from this circuit and find out the I delta value. So when I find out the I delta value, so the voltage source, so main circuit voltage sources replace their internal resistance. Voltage source is short circuit, current source is open circuit. And when you prove means the delta value, which delta we have, the delta value is I minus I dash. Otherwise, if you have the direction is downwards, suppose here the direction is downwards, same, this is also downwards, this direction also downwards, and this direction also downwards, then I delta is equal to I dash minus I. Okay, you can use any direction. So this is about compensate theorem. For any theorem, first of all, we need to get the circuit. So AC or DC. So no problem for that. So we need to know the procedure. And we know the statement. So if you know the statement and if you know the procedure, and just apply those procedure and steps and get the answer. So any theorem. So for AC, we have like impedance. For AC, we have the impedance. For DC, we have the resistors. Okay. And for any theorem, we need to prove the values means directly go for the any method. Voltage division rule, current division rule, or source transformation, or any. So there is no condition. So we know the statement. We know the procedure. So steps. First step, second step. So each step, we need to apply the conditions. Each step I need to apply the condition. This theorem means it's not like a particular circuit. or particular like a method. So in exam we have different circuits. If I practice with one circuit, in exam I have like different circuit. Not if you compare with previous paper or previous question bank or previous like any type of exam, completed exams, we have different circuit and different logic. So my suggestion is just practice well. So how much you can practice, Then if any queries this way, if you don't have any values, then comment me in comment box. I'll give those answers. And don't forget, more practice will get the more logic and more ideas. So more different circuits. So if you have the different circuits, we'll get the different answers. Okay. Suppose one particular you have one particular circuit. If I find out the response here, so using Thevenin's theorem with the same value, if Norton's theorem will get same value, Millman's theorem or any theorem, superposition theorem, you can use any theorem for we have the response, we have the like value, which value we have, current value, that is same for each places. So just remember, what is your end answer, which answer is required, we need to prove or we need to find out. So in general they ask like just find out the Thevenin's current, then at particular load just find out the VTH value and RN value, and at particular load resistance and find out the current value. Or they will ask like what is the open circuit voltage for this, just find out the VTH value for this circuit. So just find out the VTH value. Otherwise they will ask like what is the short circuit current, just find out the short circuit current. And they will ask like find out the current using superposition theorem, then just find out the current, that's it, no need to prove. Where we have to prove, just prove that theorem, that's it. Otherwise they ask for compensation theorem, they want like I delta value, just find the I delta value. Otherwise they want like a compensate voltage value, just use the compensate voltage. Okay. And for a intelligence theorem, they want like a particular branch, what is the power. So a particular branch, what is the power, just find out the particular branch power. Okay. So if you know the logic and which method I need to use. So for theorems or circuit analysis, just remember series, parallel. First one is series and parallel. Then Ohm's law, Kirchhoff's laws, star to delta, delta to star. Then mesh analysis, node analysis, super mesh, super node, current division rule, voltage division rule, source transformation. If you know this logics, the theorems is very simple. AC or DC. And for AC, particularly the AC, we require like polar to rectangular, rectangular to polar. So polar value to rectangular value, rectangular to polar value, you need to convert. Otherwise you can't get the value. Okay. And we have one more small logic, that is inspection method. So guys, we'll meet again with different topics with great questions in next videos. Okay. Keep watching my videos. If any queries, comment me in comment box. And guys, please, my suggestion is just do practice. So different circuits with different circuits. Then you will get the different logic. If you know the logic for any circuit, if you know the logic, it's very simple to find out the answers. Okay. So if you know the logic, not only like formulas, not only like procedure, if you know the logic also, we'll get the answer. Okay. Thank you guys. We'll meet again in next video. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.